Hey guys, okay, so this is question number 1 on the review packet. It says, consider a function such that f of x equals 5.8 times the sine of pi over 6 times x plus 1 plus b between 0 and 10, where b is an element of all reals. Find the period of f. Period is equal to 2 pi over b. In this case, pi over 6 is standing in b's spot, so I'm going to find the period as 2 pi over 6. And we know that division by a fraction is the same thing as multiplication by the reciprocal. These will cancel, and we have a period of 2 times 6, which is 12. The function f has a local maximum at the point 2, 21.8, and a local minimum at 8, 10.2. Find the value of b. So they gave me the max, they gave me the min. I can do the max minus the min, and that'll give me 11.6. That's going to give me the total distance between the maximum and the minimum. I'm going to divide that by 2. And I'm going to end up with 5.5.3, 5.8. So then I'm going to take the lowest number, which is 10.2. I'm going to add 5.8, and that should give me 16. So b equals 16. Hence, find the value of f of 6. Well, now if I know that b is 16, I have like the whole function, right? So I can just type the function into my calculator. Okay, I already did that for you just to make things a little faster. So I've got it here on the blue graph, right? So I can just go to Control T. I'm in the blue graph, and 13.1. And to get full credit for that, I would just have to show them the substitution, and then they know that you are using your calculator. So I would just be like this. And then I would get my answer here. All right. Now it says a second function g is given by g of x equals p times the sine of 2 pi over 9 times x minus 3.75 plus q between 0 and 10. P and q are elements of all reals. The function g passes through the points 3, 2.5 and 6, 15.1. Find the value of p and the value of q. So they gave me 2 clues, and I'm like, all right, 2 clues, 2 unknowns. I'm definitely setting up a system of equations here, right? So what I'm going to do here is for the 3, 2.51, I'm going to substitute that in and see what I get. Okay, and then I'm going to do the other clue. Let's do a different color. I don't know, pink, sure. So now I'm going to type these in. I've got 2 equations, 2 unknowns, LinSolve. So I'm going to type this into LinSolve. Let's do it. Hold on, I can't see what I'm doing. There we go. LinSolve. All right, here we go. Algebra. Okay. Then I'm not using x's and y's. I'm going to use p's and q's. What? There we go. Okay, so now I have 2.5 times the sine of 2.5 equals. Sorry, I hate that it saves all my like pre-type stuff in CAS. I'm like a little less comfortable typing everything in CAS because I always work in the CX2. But that's just the way it saves my calculator documents when I try to queue it up, so I'm not spending a bunch of hours typing in front of you guys. So it is what it is, huh? It's okay. Kind of just talking to myself. Hey, Mrs. Volchek, how are you? Did you have a good day? You know, I did. Thanks for asking. Just kidding. All right, that's the first one. And then let's do the next one. Make sure you're in radians. All right. And we get P is 8.4 and Q is 6.7. Bada boom. Six, 7. There you go. D. Find the value of x for which the functions have the greatest difference. Okay, let me walk you through greatest difference, right? Greatest difference could happen, think about two functions, right? It could happen where you have, you know, a function going like this, and then a function going like this. So the greatest difference is going to happen like maybe over here, but you might only be looking at the positive parts, right? So in order to combat that kind of like bias in your mind, you are going to want to graph the absolute value of f of x minus g of x. That's going to give you the most vertical space between the two functions, and you don't have to really like code switch between the two, right? So I've got my f of x is equal to 5.8 times the sine of pi over 6 times x plus 1 plus 16, and then g of x is 8.4 times the sine of 2 pi over 9. These are the two values that we just found above with the system of equations. I'm just like substituting them in so I can get an equation that I can graph. Right? And then here's the steps that I went through on the calculator to do this, right? So first I graphed, oh, this is from before, sorry. First I graphed the two functions, right? We have f of x and then g of x is f2, right? I'm in radians, cool. So now I'm going to go to the next tab where I subtract the two functions and I pick it up with var, right? So I do var f1 of x minus var f2 of x. Okay, and you get that. And then now that brings me to the third graph where I have f of 3 is equal to f1 of x minus f2 of x. That's the vertical distance, and then I absolute value it so that way it's super easy to see where the vertical distance is happening. Because in here, it's not totally clear if it should be the tallest peak or the lowest low, right? So the absolute value kind of takes care of that thinking for me. So now I have the absolute value of f3 of x, which is the vertical distance between the two functions f of x and g of x, and then I find the maximum of this graph because that's going to tell me about the maximum vertical distance between the two graphs, right? So back to where I was. So now I would say that I graphed, it looked kind of like this, right? And this was the absolute value of f of x minus g of x. And then I looked for the maximum, which happened to be 1.64, comma 23.4. So the maximum vertical distance is going to be, oh, it says find the value of x for which. So that means I am taking the x coordinate of this guy, find the value of x. So I have x equals 1.64.